making snowball basically using shaved ice, so I can demonstrate what sublimation is, what science calls sublimation. It's not what I call it, but I'll explain that later. Okay, here's a snowball, and you can see it's not exactly the smaller flakes like a snowflake, but it will work. Now, what I want to do is I'm going to show you what sublimation is. You take a snowball and you put a torch to it, and instead of melting, it will go from frozen to gas. Watch. No water. There's no water at all is flowing off of this. You can see, nothing. Okay. Now, what that is doing is they call it sublimation, and here's their definition for it. Okay, I took this off the internet, Wikipedia. Okay, sublimation is a phase of transition of a substance directly from a solid to a gas phase without passing through the intermediate liquid phase. Sublimation is a endothermic, I can't even pronounce it. How do you pronounce that? Endothermic process that occurs at temperatures and pressures below a substance triple point in its phase diagram. Okay, the triple point. Now, let's show you what that says. Okay. Stage fright. Okay, showing the results of substance triple point is what this says. Okay, the triple point in thermodynamics, the triple point of
a substance
is the temperature and the pressure at which the three phases, gas, liquid, and solid, of that substance coexist in a thermodynamic equilibrium. For example, the triple point of mercury occurs at a temperature of minus 38 degrees centigrade and a pressure of 0.02 MPa. Okay, look at this. And it's got a diagram over here. Shows you. All right. Now, so if that is the right thing, if they say that's the right thing, and it's absolute, what they say, then you should be able to take an ice cube and do the same thing, right? Okay, we're going to find out if we can do the same thing with the ice cube. Watch it closely. I'm going to get it down here where everybody can get focus on it. Look at it drip. Mercy, it's dripping water. That means that this doesn't apply to ice like this. So it's not the theory that they talk about. It's the size of the little ice particles. You see, those ice particles go to the applied temperature of the flame, which is approximately 1,000 degrees. This is too large. It's big matter. It won't go there. It's the secret is the size of the matter. It's the matter that makes a difference. And the smaller the matter, the faster it will go to the applied temperature. Now, I did this to gasoline 30 years ago, but I just found out about sublimation. I'm telling you, with gasoline, I separated the atoms, and that is basically how you can do it. It's you apply, I call it flashing matter. It's not sublimation. It's flashing matter, whether it be matter, solid matter, or liquid matter. and it will absolutely do it every time. It will go to the applied temperature. It's the size of the matter that does that. It's not sublimation, not even close. Because the sublimation, or the triple, whatever they said there, the triple point is not. I'm an old refrigeration man. I know that can't be done. That can't be done. Pressure, temperature. I know about pressures and temperatures, and I've been in it 50 years. And I know that won't work. Anyway, so to prove what I said, now what I'm going to do is I'm going to show you another wrong that the people have been soaked up in with. They got their the science is not right. Science is wrong in a lot of ways because they only read the books. You got to go beyond the books. I went beyond the books. And here's what I find. I find that I've separated the atoms in gasoline, and I created a fuel that does not have any smog from gasoline by spraying the gasoline onto a heater at approximately 600 degrees. Okay? Now, we're going to show you what this temperature is here. Okay, this heater okay, let's get up here. Okay, we're looking at 600 and some odd degrees in the 650 range, in 625. Okay, right in this area right here is the 625 degree range. Now what I'm going to do is I'm going to use an atomizer from a perfume bottle, and I'm going to stick it down into this gasoline over here, and I'm going to spray this right onto that heater. Now, you saw the 600 degrees. Science says, and I'll show you that, they say that gasoline will auto-ignite at 536 degrees Fahrenheit. It says it right there. Okay, and there's another, next page actually.
Let me get it.
Okay. Now the next page shows that it is the absolute. This is all the information. It doesn't totally boil, but it does vaporize at 181 degrees. It is a boiling temperature. Okay, and 93 degrees Fahrenheit, it will start to vaporize because of the type of liquids that they've used in the additives on the gasoline. You got it?
Let me get the website, make sure
Okay.
I can see that this is looked up off of Google.
Okay.
There you go.
Okay, now what I'm going to do is I'm going to put this down into the gasoline, and I'm going to take this sprayer and I'm going to spray it on this area where I move the gasoline over. Now, according to the gasoline, 536, let's see how hot that heater is, but just before I spray it on, so we know they're telling you wrong. I've seen cow rod heaters that would get to a dull red before gasoline will auto ignite. I know that for a fact. That means that there's 700 degrees that science says does not exist because it's supposed to auto ignite at 534 degrees or 536 degrees. Okay, let's take a temperature reading. Well, wait a second. Oh, I gotta measure it. Okay. Okay, there's pretty close to 700 degrees. This should auto ignite according to science. Let's just see what it'll do. Okay. This came out. Hold on. Okay, we're gonna pump gasoline right up in the 700-degree area. Hold it with one hand. Let me get a hold of it. Okay, here we go. There it is. Okay. Can't hold it on there. There it is. Look at it. Not igniting, but it's going to an instant gas. And that's above the boiling temperature. My goodness, it's going to a vapor. And that white vapor, if I cool that down a little bit, it would turn to a white vapor. And that's what I ran in 7 different automobiles. If you look at the other video, you can see it. That video was taped 30 years ago in Bandon, Oregon. It was 55 degrees that day. And what I created from the gasoline started to liquefy at 55. I figured that's approximately its temperature at which it will be saturated and go back to a liquid. But you can see gasoline doesn't ignite at no 600 or 700. It does not. Now, I'll show you what I've done to water. I'm going to spray this out so I can clear the gas out of here. There we go. Okay, all the gas is out. Now, I'm going to stick this in the water container. Okay. And I'm going to move this one or something. Yeah. Okay, I'm going to stick this down in the water, and I'm going to show you that I have come close to separating the atoms in water, because it does go to a white vapor. Like I didn't get to show you the real white vapor right there, but it goes to a white vapor, and that's what I ran in the automobile. That's the wrong hose to go in there. I want to put the lead hose in there. This is a siphon hose. Okay, there you go. Now, let's see if I can do it again. I gotta draw water into it. Okay. There it is. Okay, now watch. You'll see that white vapor that I should have showed you there, but it will appear right here. I've got it approximately 230 degrees, but I'm close. It needs more controlled temperature, but I'm there as far as getting the same kind of vapor as I had on the gasoline. See it? See the white vapor? See it? That's the white vapor that I was getting from gasoline, and I know that's close to the point at which the atoms are separating in the gasoline. Now I can use a combustible gas leak detector, but they say that the one I've got detects moisture, so I can't spray water around it because it gives false readings. So I'm just showing you that I am close, and it is possible. You can do this to any liquid. Any liquid, you can remove the atoms or separate the atoms in any liquid. All you have to do is find the boiling temperature of the atom that you want to separate in that liquid, and it will take that atom, turn it to a gas, and it will separate from the remaining liquid in the original solution. And that's how you separate atoms. Okay.